This is section 1.2, finding limits graphically and numerically. So first things first, let's talk about what a limit is with some notation. So we have here the limit as x approaches a of f of x equals L. So what this is actually saying is as x gets closer and closer and closer to this value a of a function, okay, what does the function approach? So as the x value changes, what happens to y? So let's talk about finding that graphically, okay? So evaluating using a graph. So here we have the limit as x approaches 0 of sine of x over x. So we want to look at this x-axis here, and we want to say, okay, as x gets closer and closer and closer to 0 from both sides, what happens to y? So we want to follow the graph from the left until we get to 0, okay? And then we want to follow the graph from the right side as we get closer and closer to x equals 0. And we see right here at 1. So this limit is equal to 1. All right, let's try a different one. So notice that this one is a little bit different than the last one because we have this little jump here, okay? Same thing. Now we're doing the limit as x approaches -1 of the function g. So let's follow the function in from the left side until we get to that x equals -1 right here. And then let's follow it in from the right side. Notice that while the function is not defined right here, that's still our limit because that's what the graph is approaching. So here our limit is 3 because our y value that it approaches is 3. Notice that our limit isn't 4, okay? That piece really doesn't matter to us right now because that's not what the graph is approaching. Even though that's where the function is defined, it's not going to be our limit. So that was using a graph. Now let's talk about using a table. So a table also works if you don't have a graphing calculator handy. So let's make a table. Let's look at this sine of x over x. So we already know, based off the graph, that the limit as x approaches 0 of sine of x over x, we know that that's 1 because we did that with a graph. So let's see how we can get there with a table. So I'm going to make my xy table. All right. I'm going to put what I'm approaching. So I'm going to put that 0 here in the middle. And I want to find y values to the left of it and to the right of it. So from the negative side and the positive side. So I'm going to start with -1. Okay, let's get closer. Let's do -0.1. And we want to get closer yet, so what about -0.01 and -0.001? Okay, I'm going to do the same thing on the positive side. So I'm going to do 0.001, 0.01, 0.1, and 1. Notice that 0 is undefined. So we can't plug 0 in. Remember, if you divide by 0, you get an error. It doesn't work. So let's find our values. So if we take sine of x divided by x, if you're using a calculator, make sure that you're in radians. That's going to change your values pretty quickly. So let's go here. So let's if I plug in -1, I get about 0.841, If I plug in negative 0.1, we get 0.998. Negative 0.01 is 0.999. And negative 0.001 is about 1. We're going to get 0.9999. Okay, if we plug in 0.001, we get 0.9999. Here we go, finishing the table. All right, so how do we interpret this table is the question. So we want to look, as we get closer and closer and closer to 0 in our x values, what's happening with our y values. And we can see that here, as we go down here, we're getting pretty close to 1. Same thing if we go from the right side or from the positive side, we're getting pretty close to 1 there too. So using that table, we can deduce that the limit is equal to 1. So there's also a problem, sometimes limits don't exist. So if you've watched Mean Girls, you probably know the line, the limit does not exist. So we call that the limit does not exist. You can write D and E on your homework for does not exist. What happens if we have a limit that does not exist? You're going to notice that when you make a table over here, that these are not going to approach the same number. So these two numbers right here are not going to be the same. So these are both pretty close to 1, so we can say it's approaching 1. If you get something that's not even close to each other, we're going to say the limit does not exist. So where might this happen? One possibility is that it's an oscillating function. So oscillating functions are ones that just keep going, and they might jump, or, for example, you might have a jump discontinuity. Okay, so we might have a piecewise function that's here, and then let's say the second piece is here. Okay, notice that as I follow it in from the right, I don't get the same as when I followed in from the left. So that's where we would say it does not exist. So common types of behavior, like we just said, they don't approach the same number from both sides. And then it also might happen where f of x, or the y value, decreases or increases without bound. So, for example, if we look at the function y equals 1 over x, it's going to look like this. Notice that the limit as x approaches 0, if we follow it here from the left, it's going down and down and down, down, down without bound. Here it's going up, 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 up without bound, so this would fit both category 1 and 2 here. Other than that, that should be